Hey guys, this should be something of a review for my students with some extra things thrown in, but generally will be really useful in forming your the statistics you'll need for homework 3. And I'll send out this do file. I'll attach it on Elms, so this will be available to you as well. Please don't copy this down as you watch the video. Okay, so first off, let's talk about just basically calling the data set. This is something we talked about a while ago, but I just wanted to show you a few things that you can do. So first off, you can do the sort of traditional and the probably the most elegant way is to simply just change Stata so that Stata is looking in the correct folder. In this case, it's in my Dropbox folder. And then we just do the use command. So it is called GVPT100 survey data, and we do that, and boom, we see all of our variables have been populated in into Stata here. But sometimes things will happen if you're on a PC and you double click a do file, it'll open the do file, and then if you double click the data file, it will open the data file in a separate version of Stata and the two won't talk to each other. So it's sometimes you get in a situation where it's often just easiest to drag the data file directly onto Stata itself. So what I have here is like a class folder. If I step back to find the data file, we can simply just drag it over into Stata, and again we have our variables ready to use. So that's a couple of things that you can do. Okay, so let's talk about labeling. Labeling simply means giving our variables when we call them. It gives them names within. Gives them names that we can organize. Okay, let's talk about labeling really quick. Labeling lets us sort of organize the way our data looks. It makes it easier to work with. It's, you know, if you label something and you give it to someone else, they can very quickly realize what you're doing. So this is the sort of setup. The command is label define. Then you create a definition name, and then based on whatever you're categorizing, you create the different categories this way. So the way, and then if you want to assign it to your variable, you do label value. That's the command. Then you type the variable name followed by the definition name that you just created. And I have commented in around this. So if you go back and it's not quite making sense, you can sort of read the little tags I have here. That will make it useful. So, you know, why is this important? It's often best just to go right into an example. So this V57, I've already gone to the code book. Everything can be found in the code book, which I can, you know, pull up over here, and it has all of the questions. So we have, you know, Q24, Q25. But if we go down to V57, we see that this is the if you were voting in the next presidential, or if you were voting for the next president today, who would you most likely support? And the numbers correspond to the different presidential candidates. So what we can do is, if we want to look at that variable, we can use the tab command, which just creates a little table. We can see how people responded to this question. But immediately we can see this is not really all that useful. We have, you know, okay, 55 people said they would support one. I don't remember who that was. So a way to make this way easier to deal with is to just go ahead and create a definition for that labels all of the different candidates. So I've done that for you guys here. I have label define, which is my command. I've called it pres vote, and then all the names. So I can just go up here and click execute, and it will run it directly from my do file. So I've created it. Now I actually want to assign it to my variable. Whoops. And okay, so it's assigned, and let's look at it again. Alright, so that is sort of much nicer to look at, right? We can immediately see who each of the candidates are, the number of times someone chose they would support them, and a percent. So 18% said they would support Clinton, almost 4% said Biden, 7% said Trump, etc. Okay. So what we have here is, what do we have? This Q63 is our party. So do you consider yourself a Democrat or Republican or an independent? But if we remember conversations from class, so this is just another example. So we can create this again, and we can see, okay, we have this number of Democrats, this number of Republicans, and this number of independents. But like we remember from class, a lot of people will answer independent, but they're not actually independents. If we push them and say, oh, okay, but do you lean one way? Do you lean towards one of the parties? A lot of people will say, yes, okay, actually I lean towards the Republicans, or I lean towards the Democrats. And so in order to capture this, we can create a variable that makes all of the people that answered the leaning question, it also codes them as Democrats. So what I have here is this is what recoding is. So homework 3 and homework 2 asked you about, think about the things that you'll need to recode, and this is what we're talking about, right? What we first need to do is just create a blank new variable. So we have gen here, which is short for generate. Whoops. Right, and but we don't have to type it all out. We can just do gen. And so since we're going to create a 7-point party ID scale, seems like not a bad idea. Let's call it party 7, and we're going to set it equal to this period, which just means nothing. It is Stata is going to call it. It's going to see it as a missing value. So if I tab party 7, okay, no observations, right? So now we want to populate it, and the way we do that is go to our codebook, and we look at the leaning question, and we look at the the strength questions, and we sort of use this to create our scale. So we're saying that we can sort of order people in a way. So we'd have strong Democrat, weak Democrat, leaning Democrat, independent, weak Republican, leaning Republican, weak Republican, strong Republican, right? And so that's what this variable does here. So if I have started by coding my strong Republicans first, I'm going to make them 7. So what I can do to do this is type replace the variable I just created and set it equal to 7, since we have a 7-point scale, right? And I want only the variables for question 65, which is, if you answered a Republican, do you consider yourself to be a strong Republican? And those who answered yes, we want to capture as strong Republicans. So we have replace party 7 equals 7 if this question is equal to 1, and this meaning are strong Republicans. A sort of side note here for Stata, you'll notice this has a single equals mark, and this has 2. So what we're doing is when we're creating a new variable and we're replacing some of the values within it, we can use a single equals mark. a single equals, and but when we're referencing data that is in our data set, we have to use 2. If you sort of copy and paste this and change some of the things around, you should be good to go. Just make sure that you have a double equals here. Okay, and for this question, people that responded 1 are going to be our strong Republicans. So I'm going to continue this down the line where we have 6 for that same question. They answered no, so we're going to call them weak Republicans. And then we switch questions to this leaning question. If you answered, independent, do you lean one way, right? And so for this variable, 1 was leaning Republican, 3 was pure independent, don't really feel one way or the other, and 2 was leaning Democrat. So I'm just going to keep following what I've done. 5, 4, 3, 2, 1, right? So what I can do is run this, and we can see that Stata has made some actual changes, and that seems good. Okay, so let's go ahead and tab it out, and seems plausible. Okay, yeah. So look, we have about 6.75% of our sample actually consider themselves independent, which is sort of what we would expect. We would expect, very few, probably the smallest category of people, to assign themselves into this box. But again, this is, we just created it, so we know that this is a strong Democrat and this is strong Republican. But it's really going to be more useful if we created another label, right? So I can create my label definition, which I've called Party 7 Def, and it sort of goes out here: leaning Democrat, pure independent, leaning Republican, weak Republican, strong Republican. And then I'm going to assign it to my Party 7 variable, right? Okay. So Stata has run it, and let's just test it out. Okay. So this looks much nicer than what we had before, right? So we had up here, we had about 43% saying they were Democrat, 26% saying they're Republican, 30% saying they're independent. And now we're down to 6% independent, and we have split out the different partisans into different strengths. Okay, so this is one way that we can visualize our data. This is one way to describe our data, right? Is just in this simple table. And this is something that you might want to do in your homework 3. Just sort of give us what is the distribution of people in our sample, and what is their party affiliation. Another way that we can represent this is in something called a histogram, which is just a way of graphing this in a meaningful way. So we can see, all right, our sample has lots and lots of strong Democrats, but then these two sort of are more or less the same. But what we see is fairly interesting. So lots of people over here, lots of people over here, but not very many people in the middle. So we have something that's called a bimodal distribution. I talked about that in some of my sections. But it just means that we have lots of people on one side and lots of people on the other side. So hist is another command that you could do. This is the summary command. So we can also look at this and sort of look at the mean, and in this case, like, it might not mean a whole. This doesn't really tell us a whole lot, right? Of course, the min and the max. This is not so surprising. So, like, you could do a summary for this, but it doesn't really tell us a whole lot, right? We can break it out a little further and look at the details. But again, for something like this, categorical variable, it doesn't really tell us a whole lot. So probably stick to your tables here and your histograms for something like this. But still, not unuseful. Okay, so let's go ahead and do the same thing that we have for age, because if we look at our variable for age, man, it is unwieldy. So, this is not going to be very useful for us in a descriptive manner. Like, it doesn't really tell us a whole lot. Like, I'm not going to want to have to go. I don't want to have to go and add up all of these little fractions of a percent to get everyone over 65, right? I think we can make reasonable assumptions that we can group different ages, and those different age categories are going to behave differently. I don't think that is too controversial an assumption to make. So what we can do is create different age cohorts here, and up here, we said we were using if. We were using, so we're still going to use if, but we were using equals exactly. Now we can also do the same thing while capturing a range. So if we create our blank variable, so okay, 1,481 missing variables generated, we can go ahead and start to create this. Now, the way I have set this up, the order in which you run this is very important. So essentially, what I'm going to do is, for the first category, I'm going to capture everyone in the sample who is, in this case, 17 and older, because this operator is greater than 16, not greater than or equal to 16. So this is going to make everyone in the data set, so 1,382 people, it's going to assign them 1. Now, we don't, but as you can see, we actually have 1,481 people in the total sample. So this is interesting. And if you go and you look at the age variable in the data, lots of people answered 0 for their age, and so that's not very helpful to us. So I'm just going to toss them out here. And I think that the next place to cut our sample is probably 24, 25. So what this is going to do is create a new variable, but in this time, what this is going to do is create a new variable, but it's going to start at 25. So it's going to leave everyone who is between 17 and 24, it's going to leave them a 1, and then just make everyone above them a 2. So, okay. So, we can go ahead and tab this out and see what it looks like so far. And, okay, we have lots of people remained in that first category, probably because lots of people who took this were in college, right? And this is the remainder of our sample. So I know some of you have hypotheses that might just stop here. I want to look at sort of college-age students and everyone else. And so if that is what your hypothesis is, then that's all you would have to do, right? But maybe we have some ideas that people who are 25 to 35 are different from people who are over 60, but who are also different from people who are in college, right? And so maybe we want to create some more variables. So here I'm going to keep creating new variables, and what we get is, whoops, yeah, okay. So now I'm just going to keep going up and leaving people in some areas but not in others, right? Oh, no, this was right. This was right. And let's tab it out, see what we think. Okay, so we have lots of people who answered who are in college. We have another bump here, which I'm going to guess is maybe parents of this cohort. Seems reasonable. Okay. But again, not very useful, so we have our label here. And let's look at it again. Okay. So we have 66% are in this sort of college-aged category. If you wanted to bump this down to 22, you could certainly do that. But I added a little flexibility to it. This, however you want to construct it is up to you. But yeah, so I mean, this is useful. It lets us know, okay, lots of people who took the survey are fairly young, but we do have a sort of nice bump again in this category, right? Okay. So this is useful, right? We can see how many young people we have, how many old people we have, and we can see how many different partisans we have in our group, and sort of how do the splits happen. And this is really useful things for us to know, right? So what we can also do is sort of look at these things in conjunction with one another, right? So we can see how age and partisanship relate to one another. So I have, we have lots of young, strong Democrats, a few less weak Democrats, and so on, right? And again, we see this familiar bimodal. Lots of people sitting in the partisan camp, not very many people here. But again, so this is count variables. How useful is this? So okay, we have 246 young, strong Democrats. We have 23 here, 14, 41, 25, 10. I don't know. That actually doesn't really tell us a lot. I mean, we already knew that lots of young people took it, so there's going to be lots of young people here. So maybe what's more useful is to see percentages, right? So I've added the row command here to our little bit of code, so that we can see, oh, okay, so 27% of this age cohort has identified as strong Democrat, and then this would be 18%, 17%, etc., right? Whereas the next cohort up, 23%, or 24%, I guess, have said that they are strong Democrats. 29 in this group, 26 here, 29 here, 13. Okay, so this is a little more useful, right? So if we had a theory about young people being more Democratic and old people being more Republican, this seems to bear out. So we have lots of weight here. Not so much weight here. We do have high numbers here, but really much lower probably in total. If we look the total number here, or total percent among this cohort, total percent among this cohort versus this, there's definitely a heavier weight of Democrats here, and then the opposite is true as far as Republicans. So we can see 32% say they were strong Republicans. Now, the and this is I can suppress the counts. So I had the counts here. So, but if we just wanted to look right at the percentages, I can do the no frequency command with row, so to only see this. And I want to show you something else, which is okay. So I calculated the percentages across like this, but I can also calculate them up and down. So 68%, so what this tells me is 68% of those who say they are strong Democrats are in this age cohort, whereas 6% were in this, 3% here, 4%, 11, 7, and almost 3. And this tells us something else, right? So we can see how the different ages sort out, but like again, it's really weighted towards the top because we already knew a lot of young people took it. So like these boxes are just going to be more filled up. Like, do we actually think in the real world that of all people who identify as strong Republicans, that 57% are in this 17 to 24 category? No, probably not, right? So this doing a column this way, based on the way that we ordered this, is not really useful. So here, that's why I wanted to calculate the percent across, because it's a little more useful in sort of comparison. If you guys sort of mess that up in your homeworks, I will sort of help you fix it and sort of maybe explain again why we need to flip it. You can use the column command if you really wanted to. I could do, but you would need to flip this, right? So I can look here. So this is the same thing as we had up here, 27.6, 27.06, and we compare down now instead of across. Okay, so regardless of how you do it, if you want your percents to compare up and down or across, it doesn't matter. But something like this, which is what we would call a crosstab when we have two variables in the same table, is going to be useful. It's going to be really useful for your homework. So if in this case you have an age, if your independent variable is age and your dependent variable is partisanship, then you're definitely going to want to put both of those in a crosstab and put it in your homework, because it sort of showing that, okay, it seems like there's a pattern here. That's what we want to see, right? Okay. This is just another variable that I created. So maybe you don't care about strength of partisanship. Maybe you think partisanship is the only thing that matters for your hypothesis, and that's totally fine. I mean, what you can do is collapse our 7-point back into a 3-point, but a 3-point scale that has already sorted out all the independents, right? So that we don't have a bunch of people, we don't have a bunch of leaners in our independents, right, anymore. So I think I did this. Okay, I did not label it though. Okay, and this is, okay, good. So we still have 6% say they are independent, which is what we saw earlier. And this is definitely useful. So we can do age again, sort of see how this shakes out. And okay, so yeah, so we can again see, if we go back to that age partisanship hypothesis, we can see that, okay, 62% and 64% of young people say they are Democrats, as opposed to those who are 65 and older, only 24%. Whereas they sort of sit on the opposite side and are in fact Republicans, right? So it's a little more useful to maybe see it that way, right? Okay. So for now, I've really only shown you some tables. I did show you some histograms. Maybe we can do a histogram really quick. And again, we see. Okay, this is how this works. We could do. Okay, so that we can see the frequencies. This is the number of people that responded. Okay, so I mean this certainly tells us something about our data. But so I've shown you some tables. I've shown some histograms, but we can also do a little more like in-depth bar plots, and that's what this is. But in order to do it, we have to install another package, and so pretty much just copy this code, ccs install catplot, and Stata should recognize it and install it. And what this does is lets us graph categorical variables, and it just looks nicer, I think. And so if we did a histogram age 6, we sort of compared the two. Okay, I mean it looks fine, right? But I think this is probably a little more aesthetically pleasing. So this is how our age looks. This is how party. We could also break it out into party 7, right? Yeah, and so including graphs like these is important for homework 3, because it shows that you have sort of gotten into the data. You know how your independent and your dependent variable look. And because that's just going to prepare you for actually getting in and looking at maybe how these two variables interact in the final homework. Okay, so for now I've just shown you a single variable on a histogram, but we can also sort of look at two variables. So just like we had our crosstab here, right, with age and partisanship, we can also represent it in a graph. So that's what we have here. But it's it's hard to read. It doesn't. I don't know. This is not the nicest graph in the world. So what I can do is, this is just some labeling stuff. It's going to make it look nicer. Okay, so this does actually look much nicer. And this lets us look at the distributions of partisanship across groups. So this looks good. Now, pretty much all you have to do here is, if you're not using age or you're not using party, all you would have to do here is type out your variable, right, and run it, and you should be good to go. So that's what I've done here. Maybe I'm gonna keep age, but I'm gonna go grab another question from the code book, which is Q17, and it is on a scale of 0 to 10. How much do you support the Supreme Court's ruling on gay marriage? Okay, so maybe we think that there is some age component that we might expect young people to feel differently than older people, and hopefully this graph will show us something like that. Okay. Okay. Well, we sure know that lots of young people said yes, but again, we might want to go look at the crosstab just to look at the percentages again. Oh, I'm gonna... So I can get the table on the whole screen here. Okay, so 10 I guess is really supportive, 0 is not supportive at all. And yeah, it does seem like our age works out here. So 19% of people over 65 said they didn't like it, as opposed to 68% of young people said they did. Okay, so I mean that seems pretty useful, right? We can also do interesting things with like box and whisker plots. For this variable, it seems like lots of people clustered really up here. That's just the way it's going to work because of more people said that they were supportive. So what we would probably have to do is weight this somehow to get it to look nicer. But if you can play around with these different options here. So this is not useful. Okay, well that was, I think, pretty quick. But of course, this is a YouTube video, so you can stop it and go back and try it yourself and see how things work out. If you have any questions, shoot me an email. And good luck, guys. See you on Monday.